Hey, so this is Monday, and I'm in school for just a little bit, long enough to do these recordings, and then I won't be back in here until we all come back. So, skill review, workbook pages 192 to 203. I'm going to work you through some example problems for each review. I'm not doing all the reviews in one recording, so you need to make sure that when you go into the Unit 5 folder and you choose the lesson recordings, not slides, lesson recordings, that you are choosing skill review 1, skill review 2, in that order. If you think you don't need any help with these, feel free to go ahead and solve these problems. By Wednesday, I will have an answer key on, so you can check your answers to your skill reviews. And please make sure you don't check your answers until you've actually completed the problems. You're not helping me, you're not helping you if you're just copying the answers down. This is not for a grade, this is just to help you stay fresh on the skills we've learned while we're not in class. And for Unit 5. So the first review that I'm going to do is the skill review number 1, and that is on workbook page 192. First one says, using the standard algorithm to solve the two multiplication problems below. So we are to use the standard algorithm to solve the two multiplication problems that are listed below. And I am going to do an example of a 3-digit times a 2-digit, because I think of the 2 that may be the more difficult one. And I am going to make it facts that are fairly easy, just so that I know that you are understanding the algorithm and it's not just that you don't know that certain fact is why you miss it. So I am going to take 243 times 52. And before I ever solve for this product, I am going to estimate each factor, and I'm going to get an estimated product, so that when I'm done, I can see if my final product is reasonable. I know that 231 is about 200, and I know that 52 is about 50. And when I multiply, I know that this will give me 10, right? 2 times 5 will give me 10. That's really 200 times 50. And so 100, which that represents the hundreds, and times a 10 gives us 1,000. So I know that I have to have this go to the 1,000s. 10,000s place, since we already had the 10. So I multiply 200 times 50 and I have 10,000. So I know that my answer should be about 10,000. Now I'm going to do the algorithm. 231 times 52. When we do the algorithm, it is a step-by-step procedure. You always start in the ones place with a factor on the bottom, and it is going to get multiplied by every number on the top, starting with the ones place. You are always going to multiply the bottom number by the number that is farthest to the right to start, and then work your way to the left. So 2 times 1 is 2, 2 times 3 is 6, and 2 times 2 is 4. I'm done with the ones place. I'm moving over to the tens place. And I know when I multiply by 10, the digits are going to shift one place. So these are whole numbers that are going to shift one place. I need to hold that ones place open. So I'm putting my 0 there. Now I am going to take 5 times 1, because remember I said you're going to go all the way back to the right to multiply. 5 times 1 is 5. And really what I'm saying is 50 times 1, since it's 5 is in the tens place. 50 times 1, right, does give us 50. So 5 times 1 is 5. 5 times 3 is 15. Put down my 5, carry my 1. I circle it because after I multiply, that's going to get added in. 5 times 2 is 10, plus 1 is 11. So now I have the partial products, so I'm just going to add to get the final product. 2 plus 0 is 2. 6 plus 5 is 11. I'm going to carry my 1. I like to add in what I carry right away so I don't forget to do it, because I always forget to do it if I don't do that. So I know 1 plus 4 is 5, and 5 plus 5 is 10. carry my 1. 1 plus 1 is 2. And 0, right, there's nothing here, plus 1 is 1. So I know that my final answer is 12,012. My final product is 12,012. Is it reasonable? It really is. We're going all the way to the 10,000s place, and there's only a difference of 2,000 between 10,000 and 12,012. So I know my answer is reasonable. Now we are going to look at problem number 2, and please bear with me because this eraser I am not able to make larger at this time, so I mess with it. And I know some of you are saying, oh my gosh, that old lady, she doesn't know how to make the eraser bigger. No, I don't. So bear with me. I know this is making the video a little bit longer, but I can't have all this stuff written there, and I can't get my circle to be bigger at this point. So if any of you know how to make that become bigger, let me know. I'm not using what we normally use. I'm using a different writing tool with Screencastify. So it may work what you tell me, it may not, but feel free to email me if I haven't figured it out. All right. Number 2 is a ratio table, and we're using the ratio table to help us solve the long division problem. And we are going to compare, by using the ratio table, we are going to use that information to help us solve the long division algorithm, solve it using the long division algorithm. So I'm not going to use that exact problem, but I am going to make up another problem to show you how we would do this. So let's say that I have 180, and I am going to take 180 and I am going to divide it by 15. So I'm seeing how many groups of 15 will I get from 180. So my ratio table, the top is the groups and the bottom is the total. And I'm sorry, but I'm trying to write as neatly as I can. Now, I'm going to start with one group of 15. And I know that if I have one group, it's 15. And I'm going to get as close as I can to 180, right? So now I'm going to go to 10 groups. And 10 groups I know is 150. So wow, I'm really close, right? And if I go 5 groups, 5 is half of 10. So we know half of 150, we have to take half of 150, that is 75. So the 10 groups, I will use 150, right? If I just have 10 groups. And that leaves me with 30. I have a group of 15, but this group of 150 is too much. I can't do 10 more, I can't do 5 more. But this 30, I'm excited about because I know that if I have 2 15s, that's 30. Right? So I know that my answer for this 150 represented 10 groups, and this 30 represented 12 groups. So all together, 2 groups, thinking ahead, all together I had 12 groups of 15 and 180. So I know that my quotient is going to be 12. And I could check that, right, by multiplying 15 times 12. 15 times 12. And we just did this double digit. 2 times 5 is 10. Put down your 0, carry your 1. 2 times 1 is 2, plus 1 is 3. Done with the ones place. So I know I'm multiplying by 10. And this is going to be 1 times 5 is 5, and 1 times 1 is 1. And when I add those up, I get 180, so I know my answer is correct. I also could have estimated, and I could have said, well, 180 divided by 15 is about 10, right? It's close to 10, is going to give me 18. Is 12 close to 18? Yes, so I know that my answer is reasonable. Now, as I erase this, bear with me, we are going to look at number 3 and number 4. Number 3, we are just adding decimals, and this is like our decimal of the day. And the most important thing to remember when we are adding or subtracting decimals, the most important thing is lining up that decimal point. Because by lining up the decimal point, you are lining up the places. So I know that when I add, I will be adding 100ths to 100ths, and 1/10ths to 1/10ths, and ones to the ones, and the tens to the tens. So we want to make sure that the decimal points are lined up. The most common, the most popular error that's made is not lining the decimal points up. If you estimate, right, before you solve it, you should know if your answer is reasonable. So we are going to estimate. I'm not going to solve number 3, but we are going to estimate it to see if your answer will be reasonable so that you will be able to check this. Well, when I look at 3 and 80 that's about 4, right? It's like $3.80 is almost $4. And if I look at 17 and 46 that's like 17. And 17 plus 4 is 21. So my answer should be about 21. So when you're done adding, check and make sure that your answer is reasonable. Now, number 4, we are adding a fraction plus a mixed number. So the only thing, I will do one quick example. I just don't want these to end up being too long. I'm going to do one quick example of a similar problem. So I'm going to say, let's say that I have 3/5, and I am going to add 3 and 1/4. Well, when we are adding, it's okay to add the whole numbers first. You just have to remember that if your fractions, if you get an improper fraction, you're going to have more than one whole. So those wholes need to be added to the whole number that you had to start with. So here I see I have a whole number of 3. This is 0. So I know that 0 plus 3 is equal to 3. So I know I'm going to have at least 3 wholes. And then I am going to look at my 2 fractions, 3/5 plus 1/4. We know we can't add fractions unless the denominators are the same. So 3/5 plus 1/4. I am going to count by 5s. And you may need to count more than what I count. I may need to count more than what I count unless you understand what the common multiples will be. 5, 10, 15, 20, let's say 25. Oops, we're at 20 again. 25. And I'm going to count one more after 25. So I know that right now I'm counting out 30. 25 and 30. Now I'm going to count slowly by 4s. And I stress slowly because if you count too quickly, you're going to count past the lowest multiple. It's important that you try to get the lowest multiple so your answer is closest to simplified form. It may not be simplified, but it will be a lot closer than if you don't. So we're going to count. I'm going to say 4. I don't see a 4. Next, counting by 4s is 8. I don't see 8. 5, 10, 15. Then 12. When I look above at the pink multiples, I don't see a 12. And then I know 16. I look up here. I go through these numbers. I don't see 16. The next is going to be 20. I look up at the 20. So I know 20 has to be my new denominator. And we're just going to go with the actual algorithm and our little saying to help us add these fractions. So I know that I have to find a fraction that is equal to 3/5 and that is equal to 1/4, that both will have a denominator of 20. So I'm going to start with finding an equal fraction for 3/5. So I'm going to take that fraction, multiply it by a fraction to get an equal fraction with a denominator of 20. So 5 times what? We're always going to stop down here because I only have one missing number. I can figure that missing number out. 5 times what is 20? Well, I counted by 5s 4 times. So I know 5 times 4 is 20. And whatever we do to the bottom, we have to do to the top because fractions are just division problems. So my 4/4 is actually equal to a whole, 1 whole, and any number times 1 is going to be that number. So 3 times 4 is 12. So an equivalent fraction, a fraction that's equal to 3/5, is 12/20ths. So I am going to write below that 12/20ths. I'm sorry this is messy, but I have a limited amount of space. Now I need to look at the fraction 1/4. So now I'm going to look at the fraction 1/4. Let's see if this shows up. I'm actually going to erase a little bit because this is a little frustrating that I have all this writing up here. So we'll just talk about how many times we counted by 4s to get to the common denominator, common multiple, least common multiple, which is in this case 20. So I'm going to take this fraction 1/4, once I change it back over to writing, and guys, I'm really trying to not make this fast. I mean, not make this slow. Honestly, I'm trying to not make it slow. So we're going to take this fraction 1/4, multiply it by a fraction to get an equal fraction with a denominator of 20. And I know that 4 times 5 is 20, and whatever I do to the bottom, I have to do to the top. 1 times 5 is 5. So what fraction is equal to 1/4? 5/20ths plus 5/20ths. And I know that 12 plus 5 is 17, and my denominator is going to be 20. We never, ever add or subtract denominators. That denominator says each whole has 20. So a whole would be 20/20ths. And when I take 12/20ths and I add 5/20ths, I get to 17/20ths. I'm pretty close to a whole, but I'm not there yet, right? So I come back to my answer. Don't forget this part. We've added the 3. We added the whole numbers. And since I don't have another whole with 17/20ths, I'm going to make that pink again. I am just going to write 17/20ths. So my final sum is 3 and 17/20ths. If we estimated 3 and 1/4 is about 3, right? And 3/5 is about 1. And if I take 3 plus 1, I get 4. And 3 and 17/20ths is darn close to 4, right? Alrighty then. Next, we're going to look at 5. Multiply and show your work. Don't worry about simplifying it. Honestly, do not worry about simplifying it. If you know how, great. If not, just multiply them. And let's stop and think. What do we know when we multiply fractions? A fraction times a fraction. So I'm going to be doing the work for 5 and 6 on this side. So when you multiply a fraction times a fraction, we're taking part of a part, right? So we're taking part of a fraction. So we know our answer is going to be less than 1 whole. We also know, remember when we went through all these and found these rules, we also know that our product will also be less than both factors. So that's kind of like our estimate, okay? So I am going to take 3/4 and I am going to multiply it by 4/6. And I know that 3 times 4 is 12 and 4 times 6 is 24. And I just realized I just did that problem for you, so feel free to make up your own and make sure that these will be later anyways, so I'm not going to worry too much about it. Number 6, we have a whole number times a fraction. I am making up my own problem this time. So for number 6, I know that I'm going to use a whole number, and I like the whole number 5 a lot. So this is actually problem number 6. I am going to take the whole number 5, and I am going to multiply it by 2/3. Now, we know that we can make 5 into a fraction because fractions are just division problems. We also know that whenever we take a fraction times a whole number, I'm taking part, right? A fraction's part. I'm taking part of 5. So my answer has to be less than 5, right? But it's also going to be greater than 2/3. So my product, when I am done, is going to be less than 5 because I'm taking part of it, but more than 2/3. So that's the way we can check. And we know fractions are just division problems. So what can I divide 5 by and still get 5? 1, right? When we multiply fractions, we just multiply the numerators. So 5 times 2 is 10. And I'll put up here how we got that, although I know you guys are all pretty good at this. 5 times 2, that's how we got 10. And then we're just going to multiply 1 times 3 to get the denominator of 3. And how did I get that 3? It was 1 times 3. Now, if you look at 10/3, we know that's improper, right? So I know that I have more than a whole in 10/3. I know a lot of you know how to say 10 divided by 3 is going to be 3. That gives you 9. You have 1 left over. So we know as a mixed number, this is going to be 3 1/9. But I'm going to show you how to do it if you do not understand how to do the 10 divided by 3. We know that if 3 is the denominator, 3/3 is a whole, correct? So if I have 10/3, I can subtract 3/3 because repeated subtraction is the same as division, right? We're subtracting the same over and over again. Okay, and that leaves me with 7/3. This is a whole, 3/3 is a whole, so far I have 1 whole. I can take away another whole, 3/3, and that's going to leave me with 4/3, and this is another whole. So far I have 1 whole plus 1 whole. Now 4/3, I can still take away 3/3, and that leaves me with 1/3, and this gave me another whole. So 1 plus 1 plus 1 is equal to 3, and then don't forget your 1/3 up here, so 3 1/3. I got the exact same answer because I know that 3 1/3 is the same as 3 1/3 up here. Which equals 10/3. I was trying to erase this, so let's get the eraser, Mrs. Picou. Okay, so I know that 3 1/3 is the same as 10/3, right? I think I may have had 10/9 there, so sorry guys, I'm trying. I'm also just trying to not make these long. So I know 5 times 2 is 10, and 1 times 3 is 3, so my answer is 10/3. And that is the same as 3 1/3. Okay. I'll do a drawing for this stuff later just to help you understand, since I kind of messed that up a little bit, but I'm going to go on because these recordings do take a while. Okay, and then number 6 is multiplying a whole number times a fraction. And we know that when we multiply, right, a whole number times a fraction, that it is going to equal less than the whole number because we are taking part of a whole number. So I'm going to make up my own example once my writing tools cooperate and let me erase. So are they going to let me erase? No. Let's try this again. I'm not sure why, but all of a sudden my eraser isn't working, children. So I'm not doing this over, so I'm sorry, but I'll do my example down by number 6, and I may record this later at home, but it just won't have the writing along with it because I won't be able to do that at home. Number 6 is 4 times 3/5. So I'm going to use a different number, 5. I've already done number 6, so ignore me. And I am done with this example. Sorry for the confusion, children. Hopefully this helps some.